Ryan said he has a turn to rational work.
Okay. So we are going to get into rational expressions. We're going to spend a couple days on this. You guys have to kind of tell me what you remember and what you don't. I have tons and tons of examples. If we're good with something and want to move on, great, but I am not going to assume you remember anything. Okay, I am teaching it all just in case we happen to forget something. All right.
This is where my algebra 2 trauma started.
What is a rational function or rational expression?
Anything greater than 0 that's not a negative or integer.
You're thinking.
Sorry, a rational function is a whole number,
You're thinking of rational number.
I know.
Rational
Not
has
pi.
the word ratio in it. We have a fraction. Okay.
Not pi.
What's the word for the top of a fraction? Numerator. The bottom is the denominator. Okay. When we are talking about these rational expressions, something that we will touch on a lot is the domain. Okay, so when we're talking about the domain of a rational expression, we know rational expression means we have a fraction. If we're talking about the domain, what can't happen in a fraction? The denominator. So the denominator, or the bottom, cannot be 0. Okay, so if I gave you if I asked for the domain here, this is a rational expression because I have a fraction. Can you tell me what x cannot equal?
0
Negative 4, negative 2.
Yeah, how'd you get it?
Because the denominator can't be 0.
It does not matter that x plus 4 could reduce. We'll talk about reducing here in a second, but domain is based off the original problem. So when I look at this, we have to look at the bottom. Each parenthesis, we know that if you're multiplying, if either one of those is 0, the whole thing equals 0. So for the domain, x can't be negative 4 or a negative 2. If you plug either of those numbers into the problem, you end up with dividing by 0. If you divide by 0 on your calculator, it's going to tell you domain error. It cannot do that. All right, so the first thing we're going to do is give the domain of some rational expressions and also reduce them. If I asked you to reduce this, what could happen? You could cancel the x plus 4, so your reduced form is x plus 6 over x plus 2. If I ask for lowest terms, okay? Just like if I said 10 over 5, you guys know you could reduce that to 2. Okay, that's all we're doing on these. So we're going to practice reducing them and giving the domain. Remember, the domain is based off the original problem, not after we reduce it. Okay, so this one's not as obvious what x can't be. So what should we do? If we can get things factored, then it's a little more obvious what x can't equal and how to reduce. So do we have a GCF on the top?
No.
All right, what numbers would multiply to 4 and add to 4?
2 and 2.
So this factors into x plus 2 times x plus Alright, on this one, what would multiply to 2 and add to 3?
2.
Alright, so 2 things you're asked to do. The domain we need to do right now. What can x not equal?
-2, -1.
Then the lowest form, so if we reduce this, what cancels out? Okay, not all of them, just one. So my lowest form is x plus 2 over x plus 1. So, let me ask you a question. At this final answer, could I plug -2 in here? Would that be legal? So why did I say x couldn't be negative? If you go to the original problem, could you plug a -2 in? No. So your domain is always based off the original piece.
Can your domain be a negative number? Just
Yes.
not zero?
The bottom of the fraction can't be 0. So as far as what you're telling me x can't equal, it could be any number. It's just whatever makes it 0. So we can't do anything until this is factored, and we can start reducing. What should we do first?
Take out the GCF.
Alright, so what would you take out on top then?
2.
And that leaves us with,
4 minus 1.
on the bottom, what would multiply to 12 or to -12 and add to -1?
-4 and 3. Friday was ready for that, bro.
I mean, I was game.
Oh, that's easy.
I mean, I was ready for it, I just didn't say it.
Alright, can you tell me the domain here?
Yes.
4 and -3.
Okay. Can I reduce anything right now?
The domain does not equal 4 and negative.
Yes, sorry. Did I write equals?
Yeah.
So domain x cannot be a 4 or a -3. Nothing cancels. Yeah, isn't it close to canceling though? 4 minus x and x minus 4, those are almost the same. So what we could do is, if we went back on the top and instead took out a -2, then it would be a -4 and a positive x. Is -4 plus x the same as x minus 4? So now that reduces, so the lowest form is -2 over x plus 3.
Where the negative is. Like, can it be on the middle bar? Or do you
Well,
want
if
it?
You could make it like -x minus 3 on the bottom, or you could put it out in front of the whole thing. Yeah. Any of those are okay.
Negatives kind of hurt.
Let's do. You guys try one. Here's your problem. We have a GCF, so if you take out the 3, then you have x plus 3. X squared minus 9, we can do difference of squares. X plus 3, x minus 3. So my domain, right here, x cannot equal, what makes x plus 3 0? And what makes x minus 3 0? So there's the domain. X plus 3 would cancel, so this reduces to 3 over x minus 3.
I feel like I'm better at doing it when I'm doing it by myself.
Okay, let's move forward. So next thing I want to do, we're going to start doing some operations with these rational expressions.
Oh, lovely.
So let's look at this beautiful problem.
It's in my head.
Beautiful square. Quite the description. Yeah.
It is very beautiful.
It's something. It's something.
It's something, huh? How do you multiply fractions?
You butterfly. No.
If I said like
Multiply across. Yeah, you multiply.
2/3 times 1/5, you would get
Or you would
2/15. So you multiply the tops, you multiply the bottoms. Okay.
Don't you count?
So could I just start distributing everything and multiply this?
Yeah.
Yeah. Do we want to?
No.
No, not really. Okay, so let's factor first and see if anything would reduce. So maybe we have a nicer problem to deal with. So x squared minus 2x plus 1. What multiplies to 1 and adds to -2?
-1, -1.
Right. On the bottom, what could you do?
Take out
X was negative X.
Take out
Take out
the x, and then you'd be left with
x squared plus 1. Or plus x. Yeah, plus 1.
x squared plus 1. Yep. All right, what about on that one?
Take out a 4.
Take out the 4, raise common factor, and then what would we be left with?
X squared plus 1.
And then what about the bottom?
It's not two. It doesn't work.
2 and -1.
Multiply -2 and add +1, so x plus 2x minus 1. All right, so right now, we've done a lot of factoring. How is this beneficial?
We can cancel out x squared plus 1 and x squared plus 1.
Right, if I gave you like 2/6, you would reduce that to 1/3, right? We just got done writing our fractions in lowest terms. So we know if something's on top and bottom, it can cancel. Now, it doesn't matter if it's on the top in one fraction and the bottom in the other. We can go ahead and cancel them. So I could drop out an x minus 1. What else could we drop out?
X squared plus 1.
Okay, so now when you multiply the tops. So on the top I have a 4 times x minus 1. On the bottom I have an x times an x plus 2. Now could I go ahead and multiply that out pretty easily? Yes. In general, I'm going to tell you to leave your answer in factored form. That means what I'm really looking at here is, can you reduce these fractions? Can you factor them out, drop things out of top and bottom? We've already practiced multiplying polynomials, so I'm not assessing that right now. I just want you to stop here, okay? My emphasis is on getting to that point.
We have to find domain.
I did not ask for it, but if we did, your domain would be based back here before you canceled everything out. So if it's just an x on the bottom, what can x not equal? 0. X squared plus 1, does that ever equal 0? No, you would get x squared equals -1. And if you do the square root, we haven't reviewed that yet, but square root of -1 is imaginary, so we wouldn't have to worry about it. This x couldn't be -2, and that one x couldn't be +1. For the domain problems, I'm really going to stick with the earlier problems. I'm not going to have you do the domain when we're multiplying them. Okay? So if we can multiply,
No, don't say.
surely we can divide.
Yeah. Don't we flip them, don't we? Skip, flip, multiply.
Yeah.
Flip reciprocal is
This isn't so bad.
It's
How do you go from E to B? You go from E to B.
skip, flip, multiply. That's how I learned it.
Okay. So, this looks bad. Okay, everybody, I know, you see fractions and your anxiety level goes up a little bit, and then you see fractions and fractions and you're all the way up here. But it's really not that bad, because how do we divide fractions?
Skip, flip, multiply.
Yeah, you multiply by the reciprocal. So that means this first one stays the same. It's still x plus 3 over x squared minus 4. Then, instead of division, we change it to multiplication, and we do the reciprocal. We flip the bottom one. So the only one that flips is the fraction in the denominator. So that's one step, but now it's just like problem A that I gave you. So, we need to start factoring and reducing. X plus 3, there's nothing I can do with that. X squared minus 4, what is that?
Plus 2.
Plus 2x minus 2.
Okay, x minus 2, I can't really do anything with that. X squared minus x minus 12.
Negative
X minus 4 is plus 3.
Okay, so we factor, and then we can reduce things. So we could drop out an x plus 3 on both of them, and x minus 2. If everything drops out of the out of the top,
Whoa.
that's a 1. So the fraction doesn't just disappear, it's just a 1 on top. And on the bottom we have x plus 2 times x minus 4.
Would you want us to flow?
I'm going to say in my directions to leave it in factored form. Lots of reasons. Eventually we'll get into graphing these kinds of things, and everything that we need to find from our from our function will be based on the factored form. So it's just setting us up for those problems later on, and saving you some work along the way.
Stop it for growth.
Let's do. Alright. Let's do 1 or 2 more together.
And 30 minutes is almost done.
30 minutes, that's all I get?
Remember, that's what you said.
No.
That's your attention span.
It is your attention span. Okay.
Mine's
Nope,
getting
stop.
already.
It's a Monday, so it's shorter.
Yeah, Monday is like.
My heart math.
You're so funny.
Alright. I have found that while this problem looks more simple,
It is not.
it's actually not harder, but people are more likely to make mistakes on the easier problems. Because when it's easier, you think you're doing something wrong, and you try to turn it into a hard problem. 3 times x plus 6, what can we do with that?
Take out 3.
And that leaves us with?
X plus 2.
Okay, 5x squared. Can I really do much with it?
No.
Oh, I'm going to factor a GCF.
You could write it as 5 times x times x. You could do that.
No,
You could hurt yourself even more.
Well, that's equivalent as the x squared, so that's okay. X squared minus 4.
X plus 2. X plus 2.
Alright. What cancels here?
X
Plus
plus 2
2.
is the X.
Yes. The x is what gets people. Remember, x squared just means you have x times x. Okay, we did, back the very first day last week, we talked about rules of exponents and how if it's on top and bottom, you can subtract those exponents. That's all this is. Or you could think 1x on top, 2 on the bottom. So one of those x's would cancel out, and I'd be left with 1x on the bottom. So my answer is just 3 over 5 times x minus 2. Does everyone see how I got to there? What happened with my x's?
Yeah.
The other common mistake, if I said like 3 over 6, you would need to reduce your coefficients as well. 3 over 5 doesn't reduce, so I'm okay, but it's just the x's and the coefficients that people tend to not reduce on these problems. All right, one more.
If I see x squared minus 4 one more time, I'm gonna quit.
All right, I'll
Just
go.
6
quit.
problems.
I can. I'm trying
No,
to give you
don't
nice,
change it.
easy
Don't change it
numbers,
now, we're gonna write it
but
down.
now I know that that upsets you, so I will
Just
keep
don't-
life more interesting.
Don't do
and
it.
go with
Just
some
like
bigger
that.
Just
numbers.
don't do it that many times.
Next one will be x squared minus 144, just for you.
I mean, that one's good though, because that simplifies to
No, that's not
12.
good.
It's the same premise.
Okay, so how do I need to rewrite
What?
this?
6x over x squared minus 4 and 2x plus 4 over 3x minus 4.
Flip and multiply.
You said it was
Okay, so we have a 6x And as it's been planned out, apparently, x minus 4 I like to use, so x plus 2 times x minus 2. 2x plus 4, what should I do?
Take out 2.
And that would leave us with,
X plus 2.
alright, on the bottom, 3x minus 9
Take out 3.
times. Okay, what happens?
Take out the X and take plus 2.
Okay, so if I drop out, if that's all I did right now, then when I multiply 6x times 2, the bottom we have all these, I'm going to put the 3 in front. It doesn't matter what order, but I just like to write my coefficients in front. Anything else?
So these lines are really
12 over 3 is 4. You can only cancel things when it's in factored form. So don't, start up here thinking you can just cancel out x's and everything. You have to factor first and then reduce. All right. You guys want a couple problems?
Yeah.
Practice?
Homework?
Right.
Homework problem?
No, we need the homework. We
practice.
need the homework.
You need the home. You have more on the bottom, so it ends on the bottom. It's like 2 y's on top, 5 on the bottom, so you're left with 3 on the bottom. Is that one all right? B. So, first of all, if we want to divide, we have to flip and multiply.
No way how that works. It's not gonna work.
So you have to just flip both sides. Oh,
Yeah, you just flip the second fraction.
oh dang.
Okay, so for the first one, we have to do what with after that? Flip and slide. So I'm going to kind of come out to the side there.
Divide, that's where.
So let's see. This, if you bring down your 5, that's z squared minus 16z plus 15. What multiplies to 15 and adds to negative 16?
-1, -1.
Okay, then we have to go back and divide by the 5. So you should get 5z minus 1 times z minus 3.
You do it right, it makes sense.
Bottom, what multiplies to negative 12 and adds to positive 1?
-3 positive.
On the top, for the second fraction, you have a GCF. You could take out a 2z squared. That leaves us with z plus 4.
Wait, we need to flip it.
I already
Oh, you
did.
Yeah.
And then this one we could take out as 6z, which leaves 5z minus 1.
Pretty much take out the whole first problem.
Pretty much, yeah. This drops, this drops, those drop. So you have 2z squared over 6z, which reduces to
1/3 z over
1/3 z or z over 3. Either way.
All of that.
Okay.
plus all that.
All of that. So this is where